Hello and welcome to another episode of Peel Guest Webinar. I am Livia Guerra, Business Development Manager for Peel 3D for Americas. Wherever you are today, we thank you all for joining. Today we will cover the essential phases of the scan to pattern workflow. And to tackle this kind of subjects, we invited Mr. Peter Warburton on behalf of Peel 3D. Peter will cover the scanning and peel software process, and our special guest today, Mark Jewell, on behalf of ExactFlat, that will cover the 3D to 2D flattening process. Just a few housekeeping notes before we get started. If you have any question for our panelists today, please post them in the question or chat section. We will go through them at the end of this presentation. Peter, hand over to you to start this live webinar. Thank you.
Oh, okay. Thanks, Livia. Thank you, everybody who's attending. I'm going to just switch my camera now to another camera so that you can see my setup for this scan. And I hope you can see also my screen with the peel scanner. So we've got here this headrest. It's a Dodge Caravan headrest that I extracted from my very own Dodge Caravan. It's a nice small part that is good for a webinar. So it's the object of choice for today. And as you can see, I've got my peel scanner ready to go. It's simply a matter of connecting the cables, and my software is started and it's showing me up in the top right that my scanner is connected. I'm going to scan at a resolution of 2 millimeters. That's not the accuracy, that's the mesh that you want to scan. And these scanners are so high performance that you don't need to go down to very small mesh resolutions, because in fact ExactFlat software doesn't need it. It needs a smooth model. So we're going to get started, and it's very simple. You just click on scan and it's ready to go. Now over on the left there was a bar that shows you the distance from your object. So now you can see I'm holding up my scanner. I hold down the trigger, which is that thing there, and immediately I can see whether I'm at the right distance or not. So too close, it goes red. Too far, it goes blue, but it still scans. So I've cheated and stuck this thing into a piece of furniture so that I can just turn it around. Essentially, it makes life much easier. And I'm not going so fast, but it's fast enough. And then obviously I need to go and get the top, and I'm actually deliberately missing a bit because I'll show you a few neat tricks afterwards. And I'm doing this all from the comfort of my chair, which is pretty cool. I don't even have to stand up. So I've got, most of it. But of course, what I haven't got is the bit underneath, which I can't really get at because I'm close to the chair. So this is the great thing about this scanner. You can stop scanning, take this thing out, throw it in my stall, and get a good grip on it because it's chrome, and start. And because you had targets on it, it will instantly align. I'm actually going to turn my scanner upside down to show you that. See that? Quickly. So I'm going to turn my scanner the right way up and just fill in the bits around the chrome. Oops, I got a bit too close there. And I'm actually going to get another grip on this and do it this way. Maybe I won't. I just want to fill in that little bit underneath the chrome post, and then go to the other side and pick up the bottom of the cushion. So you see it automatically locked onto the previous targets, and I can just fill in the bottom of the cushion. And if I think I'm happy with that, and it only has to be you think you're happy with it, you can either choose preview or just stop the scan, and the post-processing time is so short that it doesn't. In fact, that is a very good scan, but imagine, you can see actually that I haven't got this little bit here, which is, I get my object in the same position, so I can actually just go and click on scan again and go and have another go at that. So locks on, and now I'm just trying to get past that piece of chrome. Oops. And I can fill in that hole. Stop scan again. I think we're probably pretty good. So I've got all I need, and as you could probably see in the video, this back part is in fact plastic. So I'm just going to show you the sort of resolution that the scanner is getting by turning on the triangles and wireframe. So that's the size of the mesh. Turn it back off. And now, because I can't really walk and chew gum at the same time, I'm actually going to play a video of how I process this now. So let me go back to my previous camera, and I hope you can see the right one. And I'm now going to play the video and comment it of how I processed this file. So I've just got to move it into the right place so I can see. So
You are on mute, Peter. Can you unmute? Yeah.
I'm sorry, it mutes when I start the video.
Yeah.
So we saw the workflow on the left. Up on the right is each workflow. So I first create a mesh from the scan, and then, as you can see, this unwanted plastic part is joined to the main scan. So I'm just going to cut the connections so that I can select and remove that plastic backplate. Now you've got some neat little tools for doing that, so it's fairly fast. I just to select everything that's connected and delete it. And it wasn't connected to the main headrest, so we're good. Now I want to look at this edge. So I'm just going to fill in, we've got a couple of neat auto hole fill things. So I'm doing a partial hole fill on that edge where I didn't get everything. And then I'm going to do a quick boundary. I'll do a quick clean of the mesh, quick boundary check and smooth that boundary, because ExactFlat doesn't want jagged textile boundaries on its patches. So there's a smoothing of the boundary, which is good enough for me. Now, I'm actually going to stop the video for just a second and talk about symmetry. This is an object that's symmetrical, and as a pattern maker, you want symmetrical patterns, even if the object, which I just scanned, is not truly symmetrical. Now, my scanner, our scanner, is good enough to pick up the differences, but you don't actually want those differences. So from this process forward, I'm going to do a symmetrical scan. I'm going to cut it in half and make all the patches symmetrical. Now, if you have an asymmetrical object, you do not need to do this. So it's just a little.
Are you muted, Peter?
I am. It seems to do it all the time when I. Okay, and the video is running. And I'm now smoothing. I've just smoothed that mesh because you could before see the seams. And again, ExactFlat doesn't want the seams. It doesn't want a serrated edge. And I'm also just improving this edge top right a little bit as well, because I want to hand over a very smooth set of patches to the ExactFlat software. So I've again smoothed that boundary. That was a little extra. And now I'm going to create a symmetry plane, and there's a great tool for that in the Peel software. You just draw a line down what you think is the symmetry, and it goes and tells you what is the real symmetry. So I've just asked it to create a symmetry plane. I draw my rough line down the middle, and it shows me, when I press apply, it shows me the real symmetry plane. And I'd say, okay, that's okay for me. So I've now created my symmetry plane, and I'm going to set my alignment. That is my X, Y, Z origin. I'm going to set onto this symmetry plane so that when I do my mirroring later, I'm in the right place. The original origin was away from the headrest. It was in fact where my scanner was when I first started scanning. So now you can see the origin XY plane has been put in the middle of the symmetry plane, and that will enable me to cut these things in half later and mirror them. So my next step is to cut the mesh at the symmetry plane, and that's called cut by plane. and I simply choose which side I want to keep, the good side, or if there's a better side that you prefer. You can alter the normal. You can flip the normal with the flip normal button and choose which side you want to keep. So I'm going to flip the normal and keep the the left-hand side, and off we go. We're okay with that. So now we have a perfect half headrest. The next step is to pick and cut all the patches. Now that's is called the cut by curve function, and basically I figure out where I want to cut, and I draw with Bezier points my seam. So I'm first going to do the small cut at the front, the small patch at the front, and it's basically pick your start point, run along with your Bezier curve. If you want to make a corner, you do a double click, and then I'm going to finish my start point over on the inside. And you can always rotate the object when you're doing this so that you can see where you're going to end up. Double click there, and it turns white to tell me I've got a good patch, and I just choose. In fact, I can alter them as well. So here I'm going and just tweaking the points that I chose. And when I'm satisfied with that, you just choose apply, and there it shows you the two patches it's going to cut. I say okay, go ahead. And now there's a little bit of patch management because there's the old patch left over and there's the new patch. So I just want to turn off the ones that I'm not going to use. That's the new patch there. And I'm now going to change its name so I don't get confused with that. I think I'm going to call it patch 1. And then I turn my attention to the remainder patch. So I can turn off my first one if I want and go work picking a patch on the next part. Hurry up video. Sorry, this is taking more time than it should. So I've got my remainder patch and my patch 1. I'm now turning my attention to the remainder patch, and I cut the next part, which was the front, the small front patch. Again, it's a question of picking points and with the cut by curve function. I double click there to make a corner because I want a corner point. And then I head down to the inside edge. And you can see that this patch is also made up of partly a curve that I picked and partly the boundary that was already there. So it's perfectly capable of accepting both. That's my next patch. Go ahead, rename. And onto the final, I think it's the final 2 after I've done this. It's a good idea to rename the patches so that you keep track of everything. And off to the next one, which will be that seam from the bottom of the first patch all the way around. And there you need to be fairly careful and pick right in the corner, your start point. And then you can just head off in the direction you want to go. And so you're not obliged to cut the same size or even position of patches as existed on the existing headrest. I actually am cutting along where the seams were approximately, but if you wanted to redesign your patching process, you're free to do so, of course. You could do more patches if you wanted. Okay, that might need a little bit of adjustment. You can always go back, and before you've done the cut, you can always go back and adjust things to be exactly the way you want them. You can either move them sideways or along back and forth along the line. And when you're happy with where you're going to cut this patch, it's simply a matter of choosing apply. I could have speeded this up a bit, but I don't want you to think that I'm doing smoke and mirrors on you here. So you're seeing the speed that it goes at. Okay, I'm happy with that. Oh, apparently not. I'm told that pattern makers are perfectionists, so just got a demonstration of it. I should have speeded this up, shouldn't I? There we go, apply. So that's I think, our last one. So now we've got all of our patches as separate meshes in this list of meshes. And as you can see, I can select and turn them all or some of them on and off just to check where everything is. And the next, I'm going to rename them. Okay, so I've got all my patches and I've turned them all on. I'm missing one. So there you are. So now those are four separate patches, and we're now going to mirror them around that origin, that XY plane that I'd put on the right side there in exactly on the symmetry plane. And of these four planes, of these four patches, three have a common edge. So those I'm going to mirror and sew, which is the mirror and sew function in our mirror function. And I'm going to not keep the original mesh. So when I do that, I'm choosing to do that around the XY plane, which I previously found there. It's done it, it's sewed it together. So I've recreated now a perfectly symmetrical version of that large patch. Next, I go on to the front or back patches. Yes, because those share a common edge. So those will be mirror and sew. It's the mirror function around the XY plane. Choose mirror and sew. Do not keep the original mesh. Choose apply, and it's recreated the patch. Same for the next one. Which is down there. Mirror function, mirror and sew, keep original mesh around, do it around the XY plane, and we're good. Apply. There now only remains the side panels. Now those do not have a common edge, so they should use the flip function. We'll just turn it on. There's the side panel that we've kept, and we're going to this time do flip only and keep the original mesh because you don't want to remove the previous one. Okay. around the XY plane, and apply. So now we have, when we choose OK, we have all our planes have been symmetrized, if you like, or mirrored and sewn. So we now have 5 patches. And there they all are, and I can select them individually. So the next step is to combine all those patches into a single OBJ file. So I just choose the ones I want to combine from my list, which is where the good naming convention helps, because you've got other meshes in that. And there they all are, and they're shown to me in different colors. And I say, okay, that's what I want. It's looking quite good. Apply. And now it has created a single file called combine, but which has borders in it. So I'm turning off all the previous solitary patches, and we're now looking at a single file. And yet if I choose with my select tool, I can select individual patches within it. So there it's choosing the main patch, and I can go on and choose other patches. So they're all in a single file, but they have a border between the patches. And this then you simply export in OBJ format, and it must be OBJ. You cannot use STL. And you export that in OBJ format, and you send it to ExactFlat. We are just going to have a quick look at the mesh again, just so that you understand what is happening here. I'm going to turn on those triangles, and if you zoom in, you can see that seam. So it knows that it's only that one has been sewn, so it won't appear different. It will appear as one single patch. But the other ones have not been sewn, so they have separate boundaries and adjacent boundaries. So this is the file that you would hand over to the ExactFlat software, an OBJ file, and you're ready to go over to Mark, who will show you all the magic that you can do with that file in ExactFlat.
Thank you. Thank you, Peter. So now I'm making Mark as presenter. So Mark, hand over to you.
All righty. Well, thank you very much, Livia, and thank you, Peter. That was an awesome demonstration of the Peel scanner and software. I guess you can see my screen now, I hope.
Yes, we can.
Yes, yes, we can.
All right. So this is the file that Peter sent over. I'm just going to go into my perspective view, and I'll shade it so we can take a look. So this is the, this is the file here, and you can see the seams that Peter's added. And those we're going to split those apart and create the flat file from this. So the first thing I'm going to do, because this is a single file, as Peter had mentioned, he joined everything. So the first thing I have to do is explode that into those 5 patches. What I do over here, I have my explode icon, or I can actually type explode up here, but I'll just use this. And now, if I look, I will have separate patches for all these pieces. ExactFlat, this is ExactFlat in Rhino. So we have 2 versions, one in Rhino and one that runs in SolidWorks. I'm using the Rhino version right now. And in the Rhino version, we have our meshing tools, we have our flattening tools, and we have our highlight tools. So our meshing tools, as Peter showed, this is a fairly dense mesh. It's a nice mesh. What we're going to do is we're going to adaptively remesh this. And what the software, what ExactFlat's going to do is take this mesh and decimate it down to a mesh size that's easy to handle for ExactFlat, but it's not going to lose any fidelity of the mesh. So the first thing I'm going to do is weld the vertices. So just typing in weld vertices. That's what I like about Rhino. If I can't remember where the icon is, I can actually just type in type it in. So I'm going to select this mesh. I'm going to weld the vertices here. And oh, let me try that again. I think I spelled weld vertices wrong. There we go. Okay, so we'll select these and just hit enter on our keyboard. And now all these vertices are welded. The next thing I want to do is, I said, we'll adaptively remesh this. So I'm going to, here's our meshing. We have a uniform remesher and an adaptive remesher. I'm going to select the adaptive remesher. I'm going to select the headrest. I'm going to hit enter on my keyboard. And in a second, we'll have my adaptive remesh settings. So these are the pieces that Peter's created. The software has decided this is the best defaults for this headrest, and I'm just going to hit start. And in a second, you'll see what it's going to do. It's going to recreate this mesh or regenerate the mesh. So it's going to disappear for a second and do a few calculations. And in a couple more seconds, we should see the headrest reappear.
Meanwhile, I just wanted to say there are some people that had trouble with the they don't hear anything. So I hope everyone can hear now. Just let us know by the chat or the question that everything is okay with you guys. Thank you. Sorry, Mark.
Okay. Oh, no problem. So the mesh has been remeshed. You can see it's a lot less dense. I'm just going to hit OK here, and I'll shade this again so we can see that we haven't lost any of the fidelity in the mesh, and we still have the split lines. And the reason I reduce the mesh is that ExactFlat flattens the polygons, so the mesh itself is made up of a bunch of triangles. So if you have the less number of triangles you have, the faster the flattener will go. So what I'm going to do is I'm going to flatten this now. So I'll go into my next set of tools, which is my flattening tools, and I'm going to select this first icon, which is select pieces for flattening. And I'll just highlight the mesh again and hit enter. And as soon as I did that, if you look over here in my layers, I'll just open this up a little bit. I have a pattern layer and a model layer. So the pattern layer is what I'm going to be working on. So I'll make that the active layer, and I'm going to turn off my other two layers. And I'm just going to zoom to extend so we can see this. And I'm going to shade it because ExactFlat runs like an FEA analysis, and it's going to show the strain on the seat or on the headrest. So once I turn this on, you can see the strain on the edges. Now, ExactFlat's a two-step flattener. The first step gives us what we call a projected flat, and that's what we're looking at now. The second step's when I go in and I optimize. So I'm going to select the material that the headrest is made out of and flatten based on that material type. And that's one of the things that makes this flattener so unique and so accurate, is that you actually can address the material properties by, so if this was a leather headrest, it's going to flatten the material as if it was a leather. If it was a nylon, I'd flatten it based on how nylon flattens. The other thing I should show before we get too much further into this is if I go into my ExactFlat options, the legend here shows the different strain. So this red is about over 20% strain. Sag shows up as a gray, and complete flat is white. So if there's no strain on the part, it's white. And we want to take all the stress or strain out of the material, so when we sew it back into the 3D shape, we're not having spots where the fabric will be ripping apart, which would not be good. The other thing is, if I go to my DXF export, this is where I put my seam allowance, and the headrest is in metric, it's in millimeters. So I'm going to put a 6 millimeter seam on the part. So when I flatten it, it's going to add a 6 millimeter seam. I'll just hit OK here. All right, so let's get into the rest of the flattening routine. So now I'm going to go over here. One thing that we do also have, other than decimating the mesh, so it runs faster. I can also use one of our pre-flatteners to get the majority of the strain out of the part, and then I'll optimize. And this will speed things up a little bit, even a little bit faster. So if I click this is our Smart Fracture tool. And when I hit a piece, you'll see it actually reduces the strain and gets it almost to 100%. Well, you can actually sew that up. But I want to show the optimization part of this as well. So here's our 5 flat pattern pieces. If I go to my optimizer, which is the second tool here, and I just select all these pieces, rectangle select them, hit enter on my keyboard, it's going to bring up this spring setting and material settings. And this is where we have our material library of materials. Now the software comes with I think it's about 80 different material types. We do have a lab that we can test materials. So if you have a specific material that you like tested, we can test it for you. The cost is about $30 and it takes about 3 to 5 business days to get the results. Anyway, I'm just gonna go ahead and use this cotton, and I'm gonna hit OK here. And this is gonna bring up our spring status tool, and it'll go through. And what it's doing is it's going through, it's applied that material that I selected, which was cotton in this case, and it's going to go through and it's going to flatten these pieces based on how cotton would flatten. As I said, the part was pretty much production ready when I used my pre-flattener, but I'm just going to apply the cotton material and we'll see if there's any changes. Maybe a little bit, but not much. And that's our last piece, so we're just about done. Now, I did a test just before we got online, and to create a flat pattern for the headrest took me about 3.5 minutes. So I can do this in about 3.5 minutes. And then when I used to do work in the automotive industry for doing car seats and seating, basically to come out with a pattern for an F-150 truck would take about 28 days because we go through clay modeling and draping and taping, and that's kind of usual for the traditional way of patterning. But using the peel scanner and ExactFlat, this headrest, as I said, under an hour you would have patterns, and these patterns will fit perfectly on the piece. So once we're here, the next thing I want to do is walk my pattern, and we have a tool called the Fine tool, and it's this icon here that has binoculars, and I'm gonna change this to 20, and that'll be my offset. So when I go around and I select a piece, it's actually gonna find where these pieces get sewn together. So I'll set that all up. And then I'm just gonna rotate this so I'll select these pieces. Oops, I'll just straighten that out there and just move this over a little bit. The next thing, shouldn't say the last thing, but the next thing I may want to do is add some notches, and notches are just reference points. So when I'm sewing this, I know how the pieces go together. So I'll select our notching tool, and I'll go around and I'll add notches on these pieces. And it's kind of hard to see, but if I zoom in, there's a little red tick here, and up here you can see the other tick. So it automatically knows exactly which part it gets sewn to, and I'll put a marking on the exact point where the pieces have to get sewn to. And the last one, sorry, just move my pan this up a bit. I'll just put 2 more notches here and 1 here. So now we've got my notches. It's going to close this out. And the final step would be to export this out for my cutter or plotter. And we have this tool right here, DXF Export. So I'll select that. And I'm going to call this Peter's headrest. Peter headrest. I'll save that. And we'll just go in, File, and I'll import that. Go onto my desktop, find Peter's headrest, and it's in millimeters. Okay, so here's the flat pattern for Peter's headrest. And if we look over here in my layers, I have now a grain line, a cut line, a notch, a seam, and if I had put notch tags, they'd show up there as well. This white line's the grain line, that's the grain of the material. Again, the notches are showing up on the part, and we have our 6 millimeter perimeter or our seam allowance. And that's how the software works. And that's about it for my presentation. So,
Thank
Nice.
you.
yeah, sorry, there we go. Looked a little askew, but there we are.
Thank you, Mark. Thank you,
Oh, you're very
Peter.
welcome.
Now it's a question period. So if you have any question for our panelists, please put it on the question section or chat section. We will go through them. Mark, I received a question. Maybe you can answer. Do you need
Sure.
Rhino to use ExactFlat software?
Yes, you do. We resell Rhino as well, so we can bundle ExactFlat with a license of Rhino, and you can either use it with Rhino, and we do have a version that works in SolidWorks as well. But for scanning, I actually prefer the Rhino version for myself. I'm more familiar with Rhino, but we do have quite a few customers that are using the scanner, with the peel scanner, and using it with SolidWorks. In fact, I do believe that, correct me if I'm wrong, but there is a version of software that Peel has that runs with SolidWorks, or?
It's actually that we can export entities to SolidWorks. So, but SolidWorks doesn't handle meshes so well as Rhino. So I would go with your choice of Rhino, in fact, probably.
Yeah, I agree. Yes, I agree. I think that I do believe in SolidWorks, you also have to have SolidWorks Premium or Professional to be able to handle scan data. Where in Rhino, that data comes in natively without any additional add-ins. So.
Yeah, I actually have a question for you, Mark.
Sure.
If a material has different bidirectional moduli, in other words, it stretches differently in one direction than another, can that be taken into account with in ExactFlat?
Yes, actually, we do have the ability to take that into account. And in fact, we have the ability also in this product, in the Rhino product, where we can, we have a bias directional flattening algorithm that's used for composites. So
Okay,
we can
yeah.
do composites for layups. And I know with the Peel scanner, there's quite a few companies that are using the scanner for doing composite, for scanning for composite parts, and so forth. And I think when we were in at your office, I guess before COVID, a couple of years ago, that we were scanning some parts that were composite, like hood scoops and things.
Yeah,
for
yeah, we did. Yeah, I remember. Yeah, long time ago now.
A long time ago.
Thank you. I have a question for Peter.
Yep.
With the peel scanner, are there any object size limitation?
They're not limitations they're not absolute limitations. As you scan larger and larger objects, you have an effect called the volumetric error effect that comes in, and that is the length of the scan path. So if you were to, for instance, scan a yacht and you started from the rear and went clockwise around that yacht, you'd have a good chance of having a scan path of 20 meters at least. Now, the volumetric error is, I believe, 0.25 millimeters per meter of path. So you would have probably an unacceptable error especially if you're going round to meet something at the other side. As you noticed on the headrest, I went round the headrest and it met again on the other side. Now, there are ways of dealing with that. The first thing is don't do a complete path, start from a central point and go clockwise and anti-clockwise. That halves the path length. But essentially, I would say an automobile is about the size that you could scan with the Peel to CAD scanner, and we actually have a very fine scanner called the Peel 2S, fine resolution scanner, and that has a much smaller object size, but is really not applicable. As you can see, we were already, it's not applicable in seat coverings because we're already providing more triangles than Mark's ExactFlat needs. In fact, he then goes, we're supplying a very, very accurate model, and then he goes away and demeshes it to get a smooth, nice, symmetrical patch. So I would say, yes, there is a size limit, but meaningful. I don't think anyone upholsters objects bigger than a car. It's generally it's for seating. So I don't think it would have any effect on ExactFlat customers.
Thank you. There are other questions. What's the maximum scan volume for the Peel 3D?
Well, that comes straight back to the previous question, is there isn't a maximum volume. It's just if, as you get further away from your start point, there is the volumetric error that creeps in. The Peel scanner is made by Creaform, who's our big sister, if you like, and they have scanners that are highly, like 100 times more accurate than the Peel, but the price is also probably 100 times more. So then you can head off and scan a submarine. But for any ExactFlat sized object, the Peel 2 is excellent value and excellent precision for, and in fact more than enough precision for the job. So there isn't in Peel a concept of a volume of scan. You can keep going until you run out of memory, but you might have accuracy problems on the far side of the moon, sort of thing.
Thank you, Peter. I think this will be for Mark or even Peter. How we can create our own material with a specific strength each side in Rhino or ExactFlat, please?
That's a question for Mark.
Okay, so how can
we create our own material with a specific strength each side in Rhino, or it says EF, I suppose is ExactFlat?
All they need is the parameters of the textile. So if you're a textile inventor, you have to test your own textile and tell ExactFlat what its moduli are in bidirectional moduli, and it uses that information and only that information for the flattening process. Is that right, Mark?
Yeah, so if I just go into my database, I'll show you in a second. I'll just connect to this database, and I can show you, if I go into my materials, the physical properties. So every material has a different material, the Young's modulus and the X and Y. Basically have a Poisson ratio, elongation limits. So this is the information that the software uses to calculate how the yaw on the left, so how the material will stretch and deform in shape. And that's basically what the algorithms in ExactFlat use to create the flat patterns. So the lab that we use, as I mentioned, we have about 80 materials, say, in our Rhino database. There's companies that will send us materials, or will send a lab. We use a lab in North Carolina that does the testing, and they'll provide you, the customer, with this information, and then we will show you how to import that into your library. So you'll have your own custom materials And we don't, somebody asked us this the last week, we don't add your material into our database. So if you have a material that you've tested, you're not gonna find out the ExactFlat, the next version has your material in it, because those are your materials. We only provide materials that we have tested ourselves, and those are our own materials. And then if you have other materials you want tested, they belong to you, not to us. So hope that answers the question. If not, you can send me an email, and I can send you out a white paper or a little bit more technical details if need be.
I have another question for you, Mark. With ExactFlat, how does adding for material thickness work? I think it's related to the last question.
Yeah. There's so in our database here, sorry, right here, there's the thickness, and this is measured. This material has a 0.028 thickness, but that's 0.42. This is 1.21. So we do take into consideration the thickness of the materials as well, and those are calculated in with the when we do the material testing. Then the size of the material that's required for testing is about a 1 foot by 1 foot, so 1 foot square piece of material for doing the testing, and we asked that they would send at least 2 pieces of that material to be tested.
Thank you, Mark.
Yeah.
I have a question for Peter. Does the scanner work on any type of material? Does it include animals or human beings?
It certainly can scan human beings. What it can't, I'll tell you what it can't scan. It's easier. Chrome, glass, because obviously it can't see anything on the glass. And in those cases, it's very easy. There are specific powder sprays available, and you just spray a white aerosol powder onto the chrome or glass and scan that. And it's microns thick, so it doesn't change any dimensions. The third thing that might be important to people is it can't scan what I would qualify as fluffy hair, of which I have none. But so a shaggy dog cannot be scanned with a structured white light scanner, but dense like hair you would find on a horse it could be. So you could probably scan hides, but you can't scan fur if you're thinking of fur covering a headrest, for instance. So there is that limitation, yes, but I can't think of a textile that it can't scan. I think they're all scannable. So.
Thank you, Peter. Can we export modeled pieces from other software to Peel 3D, or does it necessarily have to be as scanned pieces?
It has to be scanned pieces. Peel 3D cannot import third-party STL files or even third-party CAD files. Yes, you would have to create your mesh in the Peel scanner, but if it's an absolute necessity, we actually have a separate piece of software that can import third-party STL files and do, well, you do what I showed you in the video, basically the same thing, but it's an add-on software and would be an extra cost, but has all the functions of Peel to CAD, which is what I showed you, and comes free with the scanner. The Peel to CAD software comes free with the scanner. This add-on software does all of that, plus it can import third-party STL files. So that might be useful for somebody who has a library, for instance, of files. And while we're on the subject of libraries, some of you might be thinking that this could also be useful for archiving existing patterns, and you would be right. So the Peel scanner would be very good at scanning all of your existing library of cardboard patterns that are clogging up your warehouse and possibly moldering. So there's a second life for your scanner in that you can digitize all your previous patterns.
Thank you, Peter. I have a question for Mark. Mark, can you export the flat pattern from ExactFlat into SolidWorks drawing files for dimensions?
Oh, yes, yeah, you can. Absolutely. So if we were using, yeah, so you can export the flat files, bring them into SolidWorks. You can dimension them as well.
Perfect. Sorry, I'm just getting the questions here.
Yeah, no problem.
Maybe for Peter, any intent to make this software compatible with Fusion 360, or maybe Mark, excuse me, with Autodesk Fusion 360?
Yeah, we do have an online version, but it's limited in the ability to, because it's cloud-based. So if you have a large file, such as when the headrest, and I don't know how large the headrest was originally, but that may not be a file that's conducive to cloud-based flattening. We're limited in the size of the file that can be imported into ExactFlat Online, and usually scan files are beyond the limitation of the of that flattener. So yeah, we do have a plugin for Fusion, and you can use it, but the files have to be relatively small.
Correct. I do have another question for you, Mark. Will
Okay.
this work for a car protective film that you apply for bumpers, bonnets, etc.?
Oh yeah, no, we actually we've worked with Peel on several companies that are doing paint protection films. So the uniqueness with the flattener is that it can flatten what they call double curved surfaces such as bumpers. And we have quite a few companies worldwide using the software to create paint protection film the templates, so the 2D templates. We also, this version of software, we have an add-in module that can do graphic wraps. So if you have a 3D model and you apply a texture to it, texture map a texture to the 3D model, we can create the flat patterns of the texture, so the graphic along with the cut file. So, and we can save that out as a PDF or as a TIFF or a JPEG, and the uniqueness with the PDF is that you get the graphic information and the cut information all in one file. So so you can go to a dye sublimation printer and print the graphic and then cut that. So yes, paint protection film is one of our fortes, I would say.
Yeah, we've seen it also for very expensive racing bikes, protecting them from stones and stuff being kicked up. And I seem to remember we scanned a NASCAR helmet for the same reason, for color decals on individualized color decals on NASCAR helmets. Yeah.
Yeah, that's correct.
One question for you, Mark, and I will try to get it right. Can you make seam on one side of the pattern by 10 millimeters and one the other side 5 millimeters, or can you choose ham?
Well, in the Rhino software, the only way that you could do that is you would export the file out without a seam, and then in Rhino you'd use their offset tools to offset the edges. And I can send a video out if the person would like to give his or her email address. I'd be more than happy to send a video showing how that's done. In our SolidWorks product, you can do exactly that. You can create a seam on one side that's, say, 6 millimeters, and then on the other side that's 10 millimeters. And there's tools that actually in the SolidWorks product that allow you to do that, but not in the Rhino product.
Can you give your email, Mark, so
Oh
people
yeah,
can.
sure.
Yeah.
Should I type it somewhere or?
No, just
You can put it in the chat, in fact.
Yeah.
you can put it in the chat. In fact, yeah, so people can contact you. I know we'll have a list of attendees, and we'll get back to you and answer if we didn't answer any of the other questions. We do still have some questions, so I think we can
Okay.
go through them.
Okay.
That was correct. Can this product be used for design of the foam and subtract the cover gets applied to?
Can you scan the phone? I guess is.
For design of the foam.
Well, it's not a CAD. Okay, the Peel scanner and the software is not a CAD CAM program. So if you're designing something, you're probably going to be in a CAD CAM program to design it. But this kind of fits into a second question that I've got in front of me. I don't know whether you can see it, Libby. It says, can you use ExactFlat with solid models that are not scanned? So I presume you mean solid CAD models. In other words, for new designs. So that's a question for Mark. Can you use ExactFlat with solid models that are not scanned? So it's not reverse engineering.
Hey, yeah, no, we can bring in any 3D CAD model. I mean, there's a wide variety, STEP, IGES, OBJ, solid part files, ProE files, any file from different CAD, as long as it's 3D, we can bring it in and we can create flat patterns from it. So yes, we can do that for sure.
I have a question for Peter. The example shown is far more resolution than what my application requires. Will need to scan portion of a large machine. Is it easy to maintain mapping while repositioning around the machine? I think it's the tracking. He's talking about the tracking.
Yes, it is. Again, you put targets on it. The scanner can track by three things: targets alone, targets and unique geometry of, and I'll explain that in a second, or even targets, geometry, and texture, which is the scanning world's word for color picture. So we almost all the time track by targets and geometry. But if I was to scan a soccer ball, which is perfectly round in theory, the scanner can't know what point of view it has on that. But if I pointed at a human face, it knows immediately because there's geometrical detail. So it can tell that it's moved sideways or it's moved, but it can't tell if it's moving along a flat table. So we always use targets. And if you're describing a large mining machine, you can certainly drop your mesh resolution and just to save memory and file size essentially, but you would have to apply targets along the object as you scanned. And if it was so I'm trying to figure out if the person asking the question wants to scan parts of a mining machine, which is perfectly feasible, or whether he needs those parts to be connected to each other. If he does, if they're somehow going to be in the same bit of fabric or as a patch, then you need to be connected all the way through. And you just simply scan along a set of targets, and targets are just put on randomly. That's the whole point, that they're random. You shouldn't put them in organized lines. And if it's a large object, there are ways to save money on targets. For instance, we have things called turtles, which are little stick-on target holders, which have 4 or 5 targets on them. And so you can take them off after scanning and reuse them on the next thing you're scanning. So for instance, the targets I'm taking off that headrest, well, they have to go into the garbage because they were sticky targets and they probably won't stick again. So there are ways of saving money if you're going to be scanning a large object by using reusable targets on something that you just stick on the surface. So I hope that answers the question.
Peter, I have another question. Is the camera, I think it is the 3D scanner, a separate purchase from the software, or is the package price? And that is a good question.
Oh, it's you mean the camera, you mean the scanner, this thing?
I think it's the scanner.
Yes, that's the Peel to CAD scanner, and it's in all the software you saw today is included with it. Oh, sorry, all the software you saw from me today is included with it. And indeed, ExactFlat sells a bundle of our scanner and its software with ExactFlat for Rhino at a bundle price. So ExactFlat can sell you the whole thing. I can sell you, we can sell you, Peel can sell you the scanner and its preparation software that you saw today.
Yeah, but it's a good question because we can mark and explain the whole package. Yeah.
Yep.
You can sell it with the whole package, including ExactFlat software.
Yep.
Sure.
I have
Do you
a
want me
question.
to? Oh, sorry.
Yeah, go ahead, Mark.
No, I was just going to add on
Yes,
to that
good.
because the way we got involved with Peel, and we've been dealing with Peel for a few years now, was that we'd be getting files from people that would send us scan files, and they wouldn't be good for flattening. So the whole idea about bundling everything was to create a package that had the scanner, the software to create your patches and add create your seams, and the flattening software all as a bundle, and offer that, because a lot of times people would buy a scanner and they would scan stuff, but they didn't really realize that they needed other scanning software to create the seams and things like this. So this is kind of why we put the bundle together. And that's what but that's what we're offering is from our end is the Peel scanner, Peel to CAD software, and ExactFlat. And if you don't have Rhino, we can put Rhino into the package as well. So that's kind of how we're working with that. But of course, if you just need the scanner, you can buy the scanner from Peter and Libya.
I have another question for you, Mark. Is DXF file exported from ExactFlat compatible with Aspire software? I don't know that one.
Yeah, Aspire software, I don't know, but I mean, I can check out if Aspire, as long as Aspire brings in a DXF, but we can also export out different formats.
IGES and STEP or
right, yeah. So in this case, when I hit this button here, export DXF, this is our own. We wrote a DXF exporter and added it into our software. The reason we did that is if you just exported this file out as if I just want file save as and I selected DXF in Rhino, you wouldn't get all the information such as the notches and the seams. But if you were just flattening something and you didn't really care about notches and seams, things like this, you could just file save as and just use the Rhino save and save it out as any one of these type of files. And they have a lot of them. Maybe they have an Aspire. I'm not familiar with Aspire, but I'm pretty sure if it's a CAD software, there's a way to save a file from our product into Aspire. And if I can check into it. If the person would like to email me, I'd be more than happy to check into that for them.
I have a last question for you two guys. What are the computer requirements to run the scanning software on ExactFlat?
I'll take the first part. The scanning software and the scanner requires the specifications that are on the Peel website under system requirements. And there's two types of specification. Some of them are critical, and the critical things are an NVIDIA card, OpenGL 4.5, and the processor's ability to process AVX instructions. Those are critical. It will not install without them. And then there's the usual memory speed stuff that if you skimp on memory and RAM and speed on your processor, well, things will take a bit longer. And the more triangles you've acquired, the longer it will take. I don't know whether you could see at the time when I had the software up, but down in the bottom right of the screen, it tells you how much of your RAM you're using and how much of your graphic processing unit RAM you're using. So you'll see if you're busting the installed software. But yes, you should pay attention to the system requirements on the Peel website.
Yeah, really important.
And Mark, is there any limitations from your side?
No, I mean, if you're running a scanner based on the parameters that you gave, our software will work perfectly fine. So if you're using a Peel scanner and you have a computer that meets those specifications, you'll be more than it's more than suitable for our software.
I have another question. I don't know if we answered that question, Peter, but I want to make sure we answer. What's the maximum scan volume for the Peel 3D?
Well, there isn't a maximum scan volume. You will run out of memory and you will get into volumetric errors that depends on what you accept as a volumetric error. So it's a size guide, and if in 2 seconds I will get onto my specs and tell you exactly what they are for Peel to CAD. Excuse me 1 second. So the volumetric error on the Peel 2 CAD is 0.3 millimeters per meter. So if you go 10 meters in a straight line along something, you will have a potential error of 3 millimeters. Now, in a straight line is probably not a big problem, especially if it's to do with fabric. But if you're going around something and coming back to the same place, that 3 millimeters might mean that the mesh won't actually meet. So that's essentially your limit. It has, in fact, in the specs, it has a recommended part size. So the recommended part size for the Peel 2 or the Peel to CAD is 0.3 to 3 meters. In other words, 1 to 10 feet. But it doesn't stop working at 10 feet. You might get error problems and memory problems if you're going to be scanning off in every direction 10 feet. So there's not the concept, in fact, of a measurement volume. This might be coming from somebody who's used to scanners that do have a wall. It's like scanning in a virtual room, and it won't scan beyond a certain distance, but that's not the case here. So again, the person asking the question might be asking about the standoff from the object being scanned, and the standoff distance, as you saw, was about 10 to 15 inches with an indicator on the screen. But everything it sees within that patch of light that you saw flashing gets acquired. So as you move around, the volume that you can scan just expands. I'm not sure if I've answered that question correctly, but the person is welcome to send us an email and put the exact details of what they need to know. But again, you can look at the specs on the website. It's got the part size and it's got the volumetric accuracy of all of our scanners.
I have just an explanation of the Aspire software. Aspire is a software for creating and cutting parts on a CNC router. Just to mention, maybe you can see.
No, I don't think it'll be a problem, but I'll definitely check as soon as we get off the meeting. And yeah, but I don't think it'll be a problem.
As a general rule, if both softwares respect the DXF, or for that matter, the STL or any other protocol, because these are all defined protocols, and if your software respects that protocol, they should be perfectly exchangeable.
And For a large object, could a different scanner be used with the software?
No. Well, a different peel scanner could be, yes, but or even a scanner from Creaform, one of their metrology grade scanners. But no, the peel software is designed for the peel scanners, and there's 3 in the range: the Peel 1, Peel 2, and Peel 2S. So that's sort of the opposite mirror question of, can it import scans from other scanners? And the answer is no. The software and a scanner go together and won't run another scanner and won't import files from another scanner.
I think we run out of time.
Yeah.
I know there are other questions. We will make sure to answer all those questions. You will get an email with the link to see again, to watch again this live webinar. And if you have any questions, you can send us by hello@peel-3d.com for Peel, or with Mark your email. Mark Jewell.
Is Mark, M-A-R-K .Jewell, Jewell at ExactFlat.com.
We'll make sure everyone gets the information so everyone can get the answer of their questions.
Excellent.
Thank you. Thank you, Mark. Thank you, Peter, for this great live
It was
webinar.
fun.
Thank you. It was fun.
And we hopefully will get another series of these live webinars with ExactFlat. Thank you.
Excellent. Thank you.
Thanks, everybody. Bye-bye.
Thank you. Bye-bye.